This lesson is determine the set of vectors are orthonormal. If a set is only orthogonal, then normalize the vector to produce an orthonormal set. Here we have vector 1, vector 2. Now we're going to use the dot product and multiply to each other. So negative 2/3 times 1/3, which is here, plus 1/3 times 2/3, which is here, plus 2/3 times 0, which is here. So just multiply across. So I have negative 2/9 plus positive 2/9 and then 0. Subtract them and it come out to be 0. So the dot product is 0. So it is an orthogonal set. Because it is 0, it is an orthogonal set. Next, we need to figure out, is it orthonormal? So multiply itself twice for each vector. Multiply itself twice for each vector. So negative 2/3, 1/3, and 2/3 multiplied twice. So it becomes out 4/9, 1/9, 4/9, and comes out to be 1. Okay. For V, same thing. Multiply itself twice. So 1/3, 2/3, and then 0. Okay. So all these numbers, I got it from each of the vector here. Okay. So 1/3 twice, 2/3 twice, 0 twice. So it comes out to be 1/9, 0 comes out to be 5/9. So these two are not the same. Since they are not the same, it is not an orthonormal set. So one more time. This is 0, then it is orthogonal. If this is not 0, then this is not orthogonal. Okay? So if it is 0, it is orthogonal. And then now we have to check, is it orthonormal? To be orthonormal, these two has to be the same. These two has to be the same to be orthonormal. If it's not the same, then you have to normalize. So one more time. If they are the same, then it is orthonormal. Not the same, then it is not orthonormal. And now, because it is not an orthonormal, we have to normalize. So all these numbers, just square them. Where did I get these terms? From the original vector up here for U and for V. Okay, so square each of them. So square 2/3, square 1/3, square 2/3 comes out to be 4/9, 1/9, 4/9, 9/9. That gives me 1. Square root of 1 is 1. Now take each of the terms. Take each of the terms from its vector. So take each of these terms. Take each of these terms. Again, take each of these terms and divide it by 1. And that's how it is written right here. You're going to take every term from U divided by this. Okay, so one more time. You're going to take every term of U divide by this. And whatever that came out, it came out to be 1. So all of these terms right here, all of these terms divide by 1. And since it divide by 1, it comes back to itself. Okay. Repeat that process again for V. So square 1/3, 2/3, and 0 comes out to be 1/9, 4/9. And then square it. So now it becomes square root 5 over 3. Okay, so square root 5, square root 3. So you're going to take every term of V, divide by square root 5 of 3. So the first term of V, which is 1/3. The first term of V, which is 1/3. So 1/3, which I did here, 1/3 divide square root 5 over 3. And since this is a fraction, so keep, change, flip. Keep 1/3. Division becomes multiply. The bottom, flip. Okay? So if you can cancel something out, do it. If you can reduce, do it. If not, go multiply across. So here I can cancel and simplify something. So now it just come out to be 1 over square root 5, which is here for the first term. Repeat that again for the second term. All right. And then the last term is just 0. So that makes it really easy. Now, just to check that these two vectors, after normalize, will it be orthonormal set? One more time. Let's check this vector, after being normalized, will it be orthonormal set? And I have it over here. So square both of them. So square each of these, square or multiply itself twice, same thing. So square, square, square. Okay, and then comes out 4/9. 1/9, 4/9 comes out to be 1. Now do the same thing for this one. Square of this, which is here, square of this, which is here, square 0, which is here. Now square of 1 over square root 5, which just come out 1/5. Square of 2 over square root 5 become 4/5. 0 is just 0. 1 plus 4 is 4. 4 divided by 5 is 1. And as you can see, these two are the same. So now it is orthonormal after normalizing. Okay, so one more time. If this is 0, then it is orthogonal. After that, find orthonormal. If these two are not the same, it is not orthonormal. If it's not orthonormal, you will normalize it. And then after you normalize it, it should be orthonormal, as you can see here. Okay, so again, this is being normalized. This is being normalized. After being normalized, multiply itself twice or square it. And as you can see, this is a 1, this is a 1. They are the same. So now it is orthonormal after normalize. Okay, so be very careful of that.